Hello, everyone, and welcome back to another episode with your girl, Audrey Codner-Gibson from ACG Math Tutoring. So we are here again for our weekly experience of getting to know a little bit more with algebraic foundations. So we're going to be doing more with those radicals. What happens if we have a radical in our denominator that is a binomial? What do? I'm going to show you. Okay, everyone, and here we are. We're going to be simplifying those radical expressions with a binomial denominator. Yes, this is going to be a step up, a little bit intense, but I'm here to walk you through it. So we're going to hit on those Common Core standards of A-APR 0.7 and A-REI 0.2. So before we get into today's lesson, we need to review what we did last time, which we were rationalizing the denominator. So we can't have a radical in the denominator. We need to get rid of it. So for this example, we had 4 over 3 times the square root of 8. So I noticed that square root of 8, that can be broken down. That can be broken down into that perfect prime combination. All right, so we have our square root of 4 and our square root of 2. Square root of 4 gives me 2, and the square root of 2, since it's prime, it comes on down. So if I need to look at it, it's going to be 4 over 3 times the 2 in square root of 2. And I can go ahead and multiply those 3 times 2 because they're both outside the radical. So now I got 4 over 6, the square root of 2. But like we said, we can't have a radical in the denominator. So what I'm going to do is I'm going to multiply the numerator and the denominator by that radical 2, or the square root of 2. Because when I do that, this square root of 2 times this square root of 2, that's going to give me a square root of 4. So let me do 4 times the square root of 2 over 6 times the square root of 4. And we know that the square root of 4, that's going to give me 2. So now in my denominator, I got 6 times 2. And in my numerator, it's still going to be the 4 the square root of 2. But now, 6 times 2, that gives me 12. So now I have my 4 and the square root of 2. But now, let's take a look. We got our 4 and we got our 12. Hey, they got 4 in common. So if I simplify that 4 by 4, that gives me a 1. If I simplify that 12 by 4, it'll give me a 3. So my final answer is the square root of 2 over 3. So you could put the 1 in front, but it's not really necessary because anytime we don't see anything, it's always assumed that there is a 1 there. So that was our solution from last time's exit ticket. And if you're new to my channel, let me back up and welcome you for taking the time out and spending a little activity to figure out how you're going to basically do some division or some breaking down of radicals that's in the denominator. So normally I just go over the exit ticket that we do from last time, and then I continue on with our lesson with some examples, some practice problems, and we close everything up with an exit ticket. So by the end of this lesson, you should say to yourself, I can simplify, right? Any of the radical expressions with binomial denominators. And again, we're going to be doing some guided notes, we're going to hit some examples, get those practice problems done, and then we finish up with our exit ticket. So here's a helpful hint. We don't want to leave any radicals or any fractions in the denominator, okay, underneath a radical. So what you're actually going to do, we have a new word in store. We have this word conjugate, okay, so it's pronounced conjugate. So what a conjugate is, if I may read, it rationalizes the denominator by multiplying the numerator and the denominator by its opposite. Okay, so you're basically creating the difference of squares in the denominator so you can get rid of the radical. So for example, if I said in the denominator we had 2 minus the square root of 3, the conjugate of this expression will actually be 2 plus the square root of 3. Notice the difference. The only difference that we have is the operations. Because remember, in order for us to do this, if I'm doing it through multiplication, is that the signs have to be opposite. One has to be positive, the other one has to be negative in order for me to do my difference of squares. So right now we're looking at words. Let's kind of look at examples so you can see exactly what I'm talking about. So we're looking at our first example, which gives us 2 divided by the square root of 2 plus 3. So I have a binomial in the denominator, and I also have a radical. So I can't just, let me just multiply the numerator and denominator by the square root of 2. The reason why, I still got this plus 3 that's kind of in the mix, okay? So this is a binomial. So I have to multiply, which is correct, but I'm going to multiply by the conjugate. So that means I have the square root of 2 minus 3. Whatever I do in the numerator, I have to do in the denominator. Same exact square root of 2 minus 3. So now I'm going to take this into pieces, because if I try to look at a whole thing, it's going to make me kind of crazy. So I'm going to take this 2, my numerator. So I'm just going to write my n, put a circle around it. So I have my 2 times the square root of 2 minus 3. So I'm actually going to do distributive property. This is where a lot of people get mixed up. They know that they can multiply the 2 in the radical 2, which gives me 2, square root of 2, but they forget to multiply the same 2, but to this negative 3, which gives me a negative 6. This is going to be the answer of your numerator. So we're good right now for this. I'm just going to put like a dotted line over it, okay? So that's my answer for the numerator. Now let's take a look at the denominator. So I'm going to put a D and circle it. So we are going to do the distributive property with our denominator. But in this case, we can speed things up. There's going to be a lovely way, a shortcut. But you know what? I always show you the long way before I show you the shortcut, because that's what I do. All right, so I'm going to distribute. So I have the square root of 2 times the square root of 2, and then I do the square root of 2 times negative 3. So square root of 2 times square root of 2 gives me the square root of 4, and square root of 2 times the negative 3 gives me minus 3 square root of 2. Remember, when you're multiplying, you got a whole number and a radical, all you're doing is putting them together. They cannot intermix. All they can be is right side by side. So now I'm going to do the same thing to the 3. I'm going to distribute to everything in that second parenthesis. So I have plus 3 square root of 2 and minus 9, because 3 times 3 gives me 9. So now we have right here in the center, we got our like terms. The reason why they're like terms, both of them have a radical 2 attached to them. So a negative 3 plus 3, that gives me 0. So it's almost like they just cancel out. I don't need to put the placeholder of 0 there because I still have my square root of 4 and my minus 9 in the mix. But the square root of 4, that gives me 2. And this minus 9, I'm going to bring down. So 2 minus 9, that gives me a negative 7. Guess what? That's your answer for the denominator. Okay? Even though I broke them up to solve them, I have to put them back together as a final solution. So I'm going to write my 2 square root of 2 minus 6 over negative 7. So like everything else when we're dealing with fractions and expressions, I always take a look to see the whole numbers. That means the 2, the negative 6, and the negative 7. Is there a number that 2, -6, and -7 have in common other than 1? No, there isn't. So guess what? That's our answer because that is done at the lowest term. So let me get rid of that. And then let me officially box it. Okay? So it all starts off with the conjugate. After you do the conjugate, now you're multiplying. So you're either doing distributive property or you're doing FOIL. But I did promise you that there is a shortcut, right? Let me show you on the next one. So we got the square root of 10 over 3 plus the square root of 6. So first off, we're going to multiply by the conjugate, which is, look in the denominator, 3 minus the square root of 6. Whatever you do in the numerator, you have to do in the denominator. So now I'm going to work on the numerator first. So that means I have the square root of 10 times, since it's an expression, I'm going to put a parenthesis, minus the square root of 6. And now I'm going to do the distributive property. I'm going to distribute that square root of 10 to everything, okay? Now, 3 times the square root of 10 gives me 3 to the square root of 10 minus square root of 10 times square root of 6. That will give me the square root of 60. Now, square root of 60, I bet you, cold hard cash, that there is a perfect in there. So I'm going to have my 3 square root of 10 come on down. But that square root of 60, I can get a perfect out of it. And I know everybody's like, oh, 60. So all you need to do is like do 25. Okay, what's 60 divided by 25, people? Wouldn't that be a decimal? Yeah, so is that a perfect prime combination? No. Okay, so let's try another one. So if I do 60 divided by, let's say, 4, I'm just saying, we got 15. And if you recall, 15 is one of those special prime ratios, or not ratios, radicals. Because the square root of 15, that will just give me the square root of 5 and the square root of 3. Both 5 and 3 are both prime numbers. So I'm not going to get anything perfect out of it at all. So instead of leaving it as 2 radicals, just leave it as 1. So now the square root of 4, that gives me 2. I'm going to bring down my square root of 15. And I'm going to bring down my 3 square root of 10. So my radicals are not exactly the same. So guess what? This is my numerator. Can't break it down any further than this. All right? So now we're going to work on the denominator, but I'm going to show you the shortcut. So for the denominator, we have 3 plus the square root of 6 times 3 minus the square root of 6. If you recall, when we did it the long way, foiling, inside or in between, they canceled out. Here's the shortcut. Ready? It's going to blow your mind. All you're going to do is multiply the first 2 terms of both parentheses. Then you're going to multiply the last 2 terms of parentheses. So 3 times 3 gives me 9. I'm going to put a minus because a positive times a negative is a negative. And then we have the square root of 6 and the square root of 6. Every time you're multiplying by a radical with the same radicand, same number underneath the radicals just basically cancel out to give me this. Because the square root of 6 times the square root of 6 gives me the square root of 36. What's the square root of 36? It's 6. So to eliminate all of this, all you have to do is just multiply. So 9 minus 6 gives me 3. So that's the answer for your denominator. So now let's put it all together. So we have 3 square root of 10 minus 2 square root of 15 over 3. So now I'm looking at the whole numbers. I'm looking at 3, I'm looking at 2, and I'm looking at 3. Is there a number that all 3 have in common other than 1? Nope, that's it. So this will be my final answer. All right, okay. So not too bad, not too bad. Okay, so I'm losing light, as you can see. So we are going to multiply by what? The square root of 3 minus 1. Good. Square root of 3 minus 1. And then all we're doing is multiplying. So you're probably saying, oh, we could do the shortcut with the numerator. Pause. Take a look at the signs. Are the signs opposite of each other? No, they're exactly the same. So for your numerator, you're going to have to do that either box or FOIL method, because my signs aren't exactly the same. So I have square root of 3, which does give me 3. Then I have the square root of 3 times a negative 1, which gives me negative square root of 3. Then here I got distributing my negative 1 to everything. So minus square root of 3. And negative 1 times negative 1 gives me a positive 1. Right here in the center are my like terms, but they're not going to cancel out. In order for it to cancel out, one has to be positive and one has to be negative. So since they're both negatives, the ones that's assumed to be in front of them, we're going to add them. So that gives me a negative 2 square root of 3. Bring down my plus 1, bring down my 3. These two are my like terms. So 3 plus 1 gives me 4, minus 2 square root of 3. So that's going to be your answer for your numerator. Now let's do our denominator. This is the one that you can do the shortcut. The reason why, one of your expressions is positive and the other expression does have a negative. So shortcut, square root of 3, that gives me 3. Positive times a negative gives me negative. 1 times 1 gives me 1. 3 minus 1, 2. So now let's take a look. We got 4 minus 2 square root of 3 over 2. So I'm looking at the 4. I'm looking at this 2. I'm looking at this 2. Do they have anything in common other than 1? Yes, they do. They have 2 in common. So if I divide each of these by 2, that's going to be a 1, that's going to be a 1, and this is going to be a 2. So my final answer is going to be 2 minus the square root of 3. Even if you left it over 1, anything divided by 1 is going to be itself. So if you want to stop the video, I'm going to turn on the light so I can stop looking like a ghost because I lost my daylight. So, and give this a try. Go ahead and pause it, and we're going to correct our answers. All right, so let's give it a try. So we're going to multiply. We have 3 plus the square root of 2 over 3 plus the square root of 2. So for my numerator, we have 14 times 3 plus the square root of 2. So we're going to distribute that 14 to everything inside the parenthesis. So 14 times 3, that gives me 42, plus 14 square root of 2. So that's my numerator. For my denominator, we have 3 minus the square root of 2 times 3 plus the square root of 2. Shortcut, 3 times 3, they're not under a radical, so it's just going to be 9. A negative times a positive, that's still going to be negative. And the square root of 2 times the square root of 2, that's just going to be plain old 2. So 9 minus 2 gives me 7. So let's put our answers together. We got 42 plus 14 square root of 2 over 7. So I'm looking at the 42. I'm looking at the 14. And I'm looking at the 7. Do we have a number that 42, 14, and 7 have in common? What do you think? You're right, 7. So if I divide this 7, that's going to give me 1. Divide this 7, that will give me 2. Divide this 7, that will give me 6. So now we have 6 plus 2 square root of 2. And you're probably saying, oh, we can reduce that again. No, we can't. Because remember, originally it will be over 1. So 6, 2, and 1, the only thing they have in common is 1. So my actual answer is going to be 6 plus 2 times the radical 2. All right? So hopefully you can say, you know what? I can simplify radical expressions, but key word is the conjugate. So when you have a binomial in your denominator, you're going to use the conjugate. If you just have a monomial, one term, that's when you just multiply the radical, okay? So we already reviewed it. We already looked at our guided notes and examples. Definitely did a practice problem. Now let's get with that exit ticket. So I just want you to do this one problem, which is 2 minus the square root of 7 divided by the square root of 7 minus 4. All right? Whatever you do, do not cancel the radical 7s. You will be incorrect. Okay? It happens. It happens all the time. That's why I have it here. So at least give this a try and then come back next time to see, hey, maybe you are correct. Maybe there was one thing you just had to tweak. Maybe you're just like, I have no idea. But if you are part of that last party, like you're not sure what's going on, go ahead and look at the video again. Remember, it's here for you to use as a resource. So again, if you are new to this channel or you came back, hey, this is great. If you like these videos, go ahead and hit the like. Go ahead and hit subscribe so you know when the next video is going to come out. Sometimes it's on a Thursday. Maybe I might sneak one on a Friday. You have no idea unless you hit that notification button. So as always, I am so grateful for your time and your attention. And if you do need any assistance and you're looking for someone to help you to tutor and to break this down so you don't feel so rushed, go ahead and message me or hit me in the comments. Or you can go to my website at acgmathtutoring.com. All right, guys, take care, and I will see you next time.